So we have silver nitrate reacting with sodium sulfate to form silver sulfate solid and two sodium nitrates. Right? And it says that a reaction has 8.001 grams of silver sulfate collected, and they want to know what mass of silver nitrate and sodium sulfate were required for this reaction. Okay. Oops. Okay, there we go. All right. So this is starting with a product mass and asking us for the mass of the reactants, right? So all we're doing is going backwards from what we normally do, going from reactants to products, okay? So if we have the mass of this guy, right? What should our first step be? Steph, sorry. Yeah, so we want to get to moles of this guy. And for that, we need the molar mass of that guy, right? And then what would the next step be?
Molar ratio.
Yep, so if we wanted, let's say we're solving for this guy first, right? So we'd want to get to moles of silver nitrate. My daughter's just like screaming wildly in the background. It's dope. And then from moles of silver nitrate, what would we need?
We gotta go to grams.
Yep. And what do we need to do that?
Molar mass.
Molar mass. Right? Everybody still coolio? So we would do this, would be our first step, right? And then our second step, instead of doing silver nitrate here, we would do sodium sulfate, right? So we would have this guy goes to this guy, goes to this guy, goes to this guy. And we need a molar mass of this guy, the molar ratio for these guys, and the molar mass of this guy. Is everybody tracking live? We cool? Alright, so let's do it. Silver has a molar mass of 107. Thank you. 107.87 times 2. And sulfur is 32.06. And we got 4 times oxygen for a total of... Ah, that'll do it every time. Yeah. That's why I draw out these steps, honestly. I think it makes it a lot easier to keep everything in line. Yeah, no problem.
It's 311.796.
right? Now, knowing that I have this step in both of these processes, I would probably just get moles of silver sulfate, and then I can use the moles of silver sulfate to do this part of each one, right? So if I know I have 8.001 grams of silver sulfate, and I know that there's 311.96 blah 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 for every 1 mole, right? That'll give me, sorry, what you got? Anybody?
.026.
0.026. Yeah, we all okay with that? Cool. So now this will be our starting point for these guys, right? So we would have 0.026 moles of this guy, and we'd need to use the molar ratio here to go to moles of silver nitrate. So going from moles of silver sulfate to moles of silver nitrate, there is 1 mole of silver sulfate for every 2 moles of silver nitrate. Right? And then for the other guy, for every 1 mole of silver sulfate, we have 1 mole of sodium sulfate, right? And I ran out of room, but I think that was all the hardest part, right? From there, you just need to figure out the molar mass of silver nitrate and sodium sulfate, and then convert to grams, right? Grams. Ding dongs. Is everybody comfortable with that? Questions?
I know that we're over 10 o'clock, and I could probably wait till Monday, but if you want, can you do 20?
Yeah, totes. This is your time, guys, right? So if y'all want to ask more questions, I'm into it.
It was the one I emailed you about because I just don't know how I'm even starting off wrong.
Yes, that is a really excellent question. Is everybody okay with moving on from 21? Everybody comfortable with how to get to the end of that? Yeah? Cool. I shall erase. Okay, so let's look at problem 20, which is a titration. Okay. And the problem has a solution of sodium hydroxide is standardized to a concentration of 0.6008 molar NaOH. And we require 33.25 milliliters of the sodium hydroxide solution to titrate 10.00 milliliters of HCl. And we're asked to determine the molarity of HCl. Right? So I think we went over a question like this when we were talking about the solutions chapter. Something similar, I think. But what is the first step to solving any molarity problem? The very first thing you always want to do.
Right, moles over liters.
Yes, get rid of stupid daddy M and put moles over liters, right? So I have moles of NaOH per 1 liter of NaOH, right? Can you guys not see my side? Sorry. Boop. There we go. So, we are trying to get to molarity of HCl, which is moles of HCl over liters of HCl, right?
I already see what I did wrong. I wrote M equals moles over liters, and I wrote 0.6008 equals, and then I was trying to find the moles.
No magic. Dimensional analysis, baby.
Yeah.
Yep. But you see how without, like, writing this part out, it's impossible to see.
Yeah.
Yeah. So we know we already have a volume of this guy, right? It's not in liters. We need to convert it to liters, right? But we have a volume. So the only thing that we need is moles of HCl, right? So how do we get moles of HCl?
Molar mass.
Nah.
What? Oh.
We need that reaction, right? We need that reaction. So if we can isolate moles of this guy, right? Meaning get rid of the liters that are on the bottom, then we can use the molar ratio of these two guys to convert moles of NaOH to moles of HCl. So we want to take the molarity of NaOH and we want to turn it into moles of NaOH, which we can then convert to moles of HCl, right? And then once we have moles of HCl, we just divide by the volume. So, what do I need on top to cancel out liters on bottom?
You need liters on top.
Sure do. So I need liters on top, right? But I got this here volume is in milliliters, right? So in order to use this guy, I got to convert to milliliters. You guys picking up what I'm laying down? Yeah? So I've got 1 liter is equal to 1,000 milliliters. And now I can use my 33.25 milliliters. So what unit do I have left now?
Mole.
Moles of?
NaOH.
Moles of NaOH, right? So if somebody wants to tell me what that equals.
You know what trips me up also is
Yes.
that if the first number has something under it,
Mm-hmm.
then I don't know which direction to go.
Yeah.
That will always trip me up. If it's like just a solo number in the front
Yeah.
and then it starts breaking up,
Mm-hmm.
it's a lot easier to see that you have to go in this path, but with like something on top and something on bottom.
Well, I mean, there's no reason why you have to start with this guy, right? We could have started with that guy. You see what I'm saying?
No.
So, okay, we started off with the molarity, right? But we
Yeah.
could have just as easily started off with this guy. Multiplication order does not matter.
Right.
So I could have written and then gone to liters and then did liters times Daddy M, right?
Oh. Okay.
Right?
Okay.
So it's in terms of the order of operation, it doesn't matter, right? So whatever way is easier for you to think about. I think, Victoria, that was kind of to your point of what you were saying for going milliliters to liters, right? That was the way that you would start this problem, right? Which is totally fine.
Anybody else just for their answer get 0.02?
That sounds right.
I did it twice and I got a different number each time.
Anybody? Jessica?
Sorry.
Did you do it?
So for when I did this,
Yeah.
I changed 33.25 milliliters to liters. And so if I were to plug that into this dimensional analysis, I would have put it on the bottom, right? So that
Nah, bro. Mm-mm. No. And this is the number one mistake that I see students make, okay? They always want to put a volume down here, right? That volume is already there. You can't put a new volume there, okay? Always molarity is moles of solute per 1 liter of solution, okay? So this liter is not going here, not ever, right? Because you already have a molarity for this guy that already has liters in it. You picking up what I'm laying down?
We'll just pretend that never happened.
It's okay. Honestly, this is a really common mistake that I see all the time, okay? So you are not alone.
So, and then that's it.
So does anybody else want to chime in Stephanie's answer here in terms of the moles?
That looks so easy, and I just like made it so hard.
Yeah, molarity problems tend to be the problems that I think students are really just like, this must be harder.
Yeah, I got 0.02.
Okay.
So when we did, I remember when we did this one last time, that was the easiest way we did, like a molarity 1, volume 1 equals molarity 2, volume 2. Can we apply this one to this too?
Totally, yeah. Again, it has to be...
So if this one is a 1, all of them is a 1.
Yes, because it's 1 to 1 to 1, we can use the M1V1 equals M2V2, and I'll show you guys that in just a second. Okay. So we have 1 mole of NaOH is equal to 1 mole of HCl. Boop, boop. And now we have moles of HCl on top, so we just need to get liters of HCl on the bottom. We have 10.00 milliliters, which is equal to this many liters of HCl. So, what do you get there? 2 molar? Jessica, do you not like this empty space?
No, I'm lost. So up top okay, thank you, Alex. We landed at the top part with 33.25 milliliters.
Yeah.
And we said that equals 0.02, but now you're saying it equals 0.02 moles of NaOH.
We canceled this milliliters with this milliliters, right? We canceled this liters with this liters.
So then all that's left is moles.
Yeah, baby.
Oh my gosh.
Alex,
What in the world?
Alex, are you picking this up? Cool. So,
Okay, so
what
we're
we
saying
did up
this is-
here gave us this 0.02 moles of NaOH. I know, I'm sorry. This is why a whiteboard is nice. I like to spread out.
Okay, now I'm picking it up. I'm picking it up. Okay.
No, this is just, you know, them's the breaks. So then once we've got moles of NaOH, we can convert that to moles of HCl using the molar ratio from the balanced chemical equation. And then I skipped a step because I was lazy and I didn't want to convert the milliliters to liters. So I just did it in my mind. So if you don't want to do it in your mind, that's okay.
Okay, but wait. How did you go from 1 mole of HCl to now liters of HCl?
This
With molarity?
is down here.
Did you freak?
Okay, that was just me.
Okay, everything froze.
I
You
froze for a second. Am I back?
Yes.
We're good? Cool.
Okay, so how did you go from moles of HCl to now liters of HCl? Is that because...
No. We didn't get rid of moles of HCl. We want the moles of HCl. See? It's in our unit. This is where we're trying to go, remember? So we're not
in your dimensional analysis, they have to line up.
Right. No, they don't. Anything that's left over after we do our dimensional analysis
is still there.
is still there. Yeah. We didn't cancel it.
Oh,
right?
Man. You just blew my mind. Okay.
We're learning so much today, you guys. I love it. I love it. What's the unit for the top? The 1 is just a placeholder because I think sometimes people are like, why blank space? I don't like you, right?
And that's why when I was looking at the answer key, I was like, 1 what? Like, what is she talking about? 1 what?
Yeah. So, I like the blanks personally, but I've had students get really upset about it. So, you're like, why did you leave that blank? You can't do that. I'm like,
Okay,
I don't know.
Okay, so this cancels out,
so there.
this cancels out, and then this is what's left.
Unit on top with a 1 as a placeholder. No, this is nothing. It doesn't matter, right? Because sometimes people don't like the blank space. It doesn't matter, right? What we're saying is this is the unit that we have left over on top, and this is the unit that we have left over on bottom. You guys picking up what I'm laying down?
Yeah.
So if I have moles of HCl on top and liters of HCl on bottom, that's the molarity.
For some reason, I was thinking that everything had to cancel out except for 1 unit. But if 2 things can remain open, then obviously it would be top, bottom, moles over liters, molarity.
Yes. Okay, this is a really cool thing for you to explain to me because I've never thought about it like that. Or if I have, it was like a million years ago. So that's a really good thing
It
for
could
me to
be
know.
the fact that, like, this is still, like, fresh to us in the last couple of weeks. So, like, when we think about it, things have to, like, cancel out like this.
Right. So I think this might actually be one of the first instances, besides maybe density problems, where when you're solving for something, you're looking for stacked units, right?
Yeah.
In the main, most of the time we're trying to cancel out everything but 1, right?
Exactly.
So that's really cool for me to know that this is the first time that you guys are seeing stacked units, right? You need both of these things, not just 1, right? That's awesome. That's super helpful. Thank you, Jessica. I know. I totally get it, Ashley.
2 moles of molarity. How do we write this out? Like, of HCl?
Oh,
So,
so
it'd be 2 HCl.
Yeah, like just 2 M's?
boop,
Okay, cool.
like
The
that.
daddy M comes back? Or is that
I mean, you could still do moles per liter, right?
Okay.
They're equivalent, right? So you could do 2 daddy M. I'm just lazy. So, right? Either one of those would be totally fine.
I wasn't sure on the quiz. I was like, how do I
Yeah, no, totes. I gave you credit either way.
Okay.
Yeah. I stack you. You did stack units for the molar mass, but we didn't really calculate the molar masses. I think there was one problem in the gases, in the gas homework where you were solving for the molar mass of a gas. Do you guys remember that one?
Mm-hmm.
Yeah. So that was probably the only other example of when you're doing these stacked units to solve for something. Right? But it's not a super common thing that we do until we get to solutions, because then we're talking about concentrations. So that's awesome. Thank you. You just gave me a teacher like brain light moment. That was really cool.
This has been very eye-opening.
I honestly, you guys, I learned so much from teaching this class that teaching the higher levels is super boring to me. Because like there's so much stuff that's hard for me to like perceive how to make better sense. You know what I mean? So like every semester that I teach this class, I feel like I get a little bit better at like honing in on what you guys get confused by. And that's, you know, that's how I get hopefully better at teaching this stuff. So but yeah, that's what keeps it fresh. Keeps it exciting. What do you think, guys? How we doing? Feeling all right? Just a reminder, there was a couple of you last class, I think, that were struggling with the log problems and how to put them into your computer. I mean, your calculator. You know what I mean. So if you're still struggling with getting those into your calculator, shoot me a text of your screen and I can show you. The one thing that that I think because I talked to Kata really quickly about this, when you're putting the log in, especially when you have something with an exponent, right? I think this is the problem from the practice exam. It's really important in some calculators that these guys are the negative sign, not the subtraction sign. Why that matters so much, I don't know, but it does. Okay? So that's the most common place that I see students struggling to get an answer. And usually if you put the subtraction sign instead, it'll give you a syntax? Whatever. Error. Oh my god. I was trying to write and look at the screen while not looking at what I'm writing. It was bad. You guys don't care. It's cool. Cool. So that's honestly, that's the one that I think people struggle with the most, is just it has to be the negative sign, not a subtraction symbol. Any other questions?
I have a random question.
Yeah, what's up?
So when you convert, say, Celsius to Kelvin,
Mhm.
I've been seeing on, like in a textbook they use 273.15.
Mm-hmm.
So just 2 is your preferred, or will we see it?
It don't matter.
You know,
So where that gets really important is when classes are dealing with Siggy Figgies. But because we were just like, oh, Siggy Figgies, there they are, bye. We're okay with not worrying about that. Yeah.
Can I just tell you how annoyed I am that my chem lab professor is like, everything needs to be in significant figures, and I was like, what's that? Like, some professors teach it and some don't. No, it's nothing against you, but like,
No, this is actually kind of,
if he's not gonna teach that to us.
it's kind of,
You know?
it is kind of on me. So basically what I've told the department is that, I'm gonna go off the record here. Does anybody have any more questions about this
Oh,
stuff?
sorry.
No, that's okay.